Hello, grade 12s. Welcome back to the Pedagogical Science Institute, and this is our second video of the Maths revision series. And today we're going to be focusing on this second chapter, which is number patterns, and we'll be focusing on sequence and series. Okay, let's take a look at your examination guideline. For 2021, you can see that number pattern will have approximately 25 marks. So it's really a lot of marks out of 150 from your paper 1. 25 marks is a lot. And then these are the things that you are expected to know from your examination guideline. They say the sequence of the first difference of quadratic number pattern is linear, so you have to know that, and we'll just further explain it during this lesson. And therefore, knowledge of linear patterns can be tested in the context of quadratic number patterns. So those are some of the things that we'll also be focusing on when we start looking at a quadratic number pattern. And recursive patterns will not be examined explicitly, so they won't go into much details with those recursive patterns, sort of like patterns where they're recurring or going to sort of like infinity like that. And also links must be clearly established between patterns done in earlier grades. You know that in your grade 10, from your grade 9 you learn about linear patterns, and then in grade 10 you also learn about linear patterns and all that. When you reach grade 11, quadratic patterns, linear patterns, and all that. So we should be able to make clear links between those patterns that you make in your early grades and the new one that we'll just introduce during this lesson. Okay. Okay, let us take a look at arithmetic sequence. We'll just start here, and this is the first question. They say prove that Sn, the sum of n terms, is equal to n over 2, open brackets, 2a plus n minus 1d. Okay, so this is an examinable question. It's very likely that you can get it on your final examination paper. They just want to check whether you understand how they derived this formula for sum of arithmetic series. So I'm just going to show you how to prove this very quickly. So if you want to prove this, you should have your equation 1 and equation 2. So your equation 1, you're just showing them that now I'm adding the terms of arithmetic series, right? So you're just gonna say now for my equation 1, let me just put this somewhere here. Then it will be Sn is equal to, what is your first term? Your first term in arithmetic series is a, and your first term in geometric, everywhere in all the sequence the first term is denoted by a, right? Then let's move our second term, because this is an arithmetic sequence. We get the second term by adding a common difference on the previous term, so it will be a plus d. So we'll be adding them up until we reach the last term, and we know that the last term is the same as Tn. So if you don't know it, the last term is the same as Tn. And what is your Tn in arithmetic sequence? Our Tn is a plus n minus 1d. So that is our Tn, right? So from this point, now you think, how can you return back from Tn, right? You are saying Tn is a plus, okay, sorry about this mistake here. So because it's supposed to be a plus n minus 1d, that is your Tn. So now to go back, how do we return back? We subtract 1 from n, all right? we are going to subtract 1 from n so that we go back, because our n is decreasing by 1, we're just moving back. All right, so if we subtract 1 from n, it will be n minus 1 minus 1, then it will be n minus 2. So to return back here, it will be a plus n minus 2 d. So there's a small space here. Let me just try to create a bit of space. Then we're showing them, we're moving like that, and it will be a plus n minus 2 d. It's a bit messy there, sorry about that. Yeah, that's it. It will be a plus n minus 2d, right? So that is your equation 1. How do you get your equation 2? To get your equation 2 now, you just copy the same formula from the last position to the first position. So it's still the same thing. For example, just if I have my Sn being equal to 1 plus 2, then I can also write it as 2 plus 1. It's still the same thing. I will get the same answer, right? Even though I start from last to first, first to last. So it's still the same thing. So even here, what you can do, you can start from last, then you add from that. So remember, we're just trying to prove this formula. Then if we start there, it will be what? It will be a plus n minus 1 d plus, if we move there, we have a plus n minus 2 d plus, we are returning back there, we have a plus d, then plus a, right? Like that. So we have our equation 1, we now have our equation 2, right? Now we can add our equation 1 and equation 2, right? Let's see what will happen. If we say equation 1 plus equation 2, we'll have Sn plus Sn, right? Because we are adding equation 1 and equation 2. Now when you add here, you make sure that you add the terms that are like corresponding, right? That are corresponding like that. So it will be a plus n minus 1d. A and a are like terms. They will give me what? 2a plus n minus 1d. So when you add the two there, the two terms there that are corresponding. Let's move now. I'm just going to use a different color to show you that now we are adding this term and this term because they are corresponding. So a and a, they will add up with each other, right? A and a will add up with each other to give us what? 2a. Let me just put it in brackets, 2a. Then now you see with d, there's no like term, but we know that from this equation, we can just expand there to say to be dn minus 2d, right? So we write it as dn minus 2d. Then we add with this d because we are adding those terms that are corresponding. Then plus, we now move now, we are going to take this one and you're going to add it with this one. It's corresponding with that one. So a and a, we add each other to give us what? To give us 2a plus. Also, you can see with this one, there's no like term for d, but we can expand there. Then it will be dn minus 2d plus what? Plus this d, right? So also, we are moving like that. We also have that one. It's our a corresponding with this term here. So a and a will give us 2a plus n minus 1d, right? Then we are done adding equation 1 and equation 2. So let's just remove, let's simplify this. Sn plus Sn, it will give me 2Sn is equal to, then I just have my 2a plus n minus 1d here. Then plus, when I remove here, when I add the like terms, I'll still get, so when I remove there, it will just be 2a plus what? Plus dn minus d, because minus 2d plus d is minus d, right? also moving that side, we have small space here. Okay, let's just see, moving also that side, it will be 2a plus dn minus 2d, see, minus 2d plus d, it will be minus d, plus we also have this one, the last one, 2a plus n minus 1 d. So that's our equation, another equation that is like simplified. Okay, so now we have our 2Sn is equal to 2a plus n minus 1d plus 2a plus dn minus d, and all that. So we can just simply now say we want to take out the common factor so that we can see if whether this thing can be the same things and in all those terms. So let's look at this one. We have a common factor of d, so it will be 2a plus, if we are writing it properly, n minus 1 if we take out d as the common factor. Then as we are moving also, we have this term here is 2a plus, if I take the common factor of d, let me quickly take out the common factor there, it will be n minus 1, take out the common factor of d. Then also that one is just fine, it's 2a plus n minus 1 d. So you can now see that all the terms now are the same. So how do we go about this? So for example, if I have Sn is equal to 3 plus 3 plus 3 plus 3, right? So if I want to write this in a simplified manner, what I can do is to count how many 3's do I have, right? So it's to count the number of terms or the number of 3's that I have, then multiply by what? By 3. Then I'll just get the answer. So how many 3's do I have? I have 4 of them. So I can just substitute by 4, then multiply by 3. Then I will get the answer of that sum without actually going to say 3 plus 3 plus 3. Just count the number of 3's, then multiply by the 3. So that's another way we can write that thing in a simplified manner. So now let us look at what we have. We have 2Sn, it's 2Sn. So we can also, you can see that all the terms are like terms, right? So it's 2a plus n minus 1d, 2a plus n minus 1d plus 2a minus n minus 1d, like that. So what you can do also, you can also write it in a simplified manner by going and count how many number of 2a plus n minus 1d do I have, right? It's n, right? Number of those multiplied by what? By 2a plus n minus 1d. So we're just counting like that, just as we did with 3. When we have 3 plus 3 plus 3, we just count number of 3's, then multiply by 3. So even in this case, it's like this. So to solve for Sn is now simple. We're just gonna divide both sides by 2. So this one cancel this one, then our Sn will just be n over 2. We can write it as n over 2, 2a plus what? Plus n minus 1d, plus n minus 1d. Then you would have proven that formula on top. So that's actually how you prove your sum of arithmetic series. Okay. Okay, let's now look at this arithmetic sequence, one of the interesting questions, and just so that you can just grab the basics of arithmetic sequence. Remember, this is a revision series, and we'll just be looking closely to this question. So they say the sequence 3, 5, 7 is given. Then the first question says determine the general term. Determine what? The general term. I'll just write my answers this side. It's I. Determine the general term. So because this is an arithmetic sequence, right? So the general term, what's the general term for arithmetic sequence? It says Tn is equal to a plus n minus 1 d. So this is the general term for an arithmetic sequence. Ta is equals to a plus n minus 1 d. What is your a? Your a is your first term, which in this case our first term is what? Is 3. So it will be Tn is equal to 3 plus n minus 1. What is your d? Your d is your common difference. So we can just simply go in there and get the common difference. You say term 2 minus term 1. You take the following term, you subtract the previous term. 5 minus 3 to give me 2. Then also if I say 7 minus 5, it should give me 2. Then I know, I'm sure now the general, the common difference is 2. So you can just write 2 there. Then you can just replace to write your general term in a simplified manner. So it will be 2 times n, 2n, 2 times minus 1 minus 2, but we have plus 3 there. Then our Tn will be 2n minus 1. 2n minus 1. So that is our general term. Okay, let us now look at the second question. They say which term is equal to 71? Which term? Which term? They need the number of term. It means they need n. Which term is equal to 71? So we need the Tn. We don't know it's which one. That's why we're saying our Tn must be equal to what? 71. Our Tn, which nth term is equal to 71. So we need n. So we already calculated our Tn is 2n minus 1. So we equate it to 71. Then we can just transpose 1 to the other side. Then it will be 2n is equals to what? 71 plus 1. It will give us 72. Then we divide both sides by 2. Then our n is gonna just be 72 divided by 2. Then it will give me what? 36. Then my n is 36. Then we can answer that question. Which term is equal to 71? It's term number 36. It's term 36 that is equal to 71. So it's term number 36. Okay. Now let us look to the third one. Which first term will be greater than 41? Which first term will be greater than 41? So this is quite a tricky question, but it's very simple because they said which first term. So normally what people do, they actually give the term that is actually equal to 41. You see, but the question here, it says which first term will be greater than 41. So it means what we can do, we can calculate the term that is equal to 41, then the next one will be the one that will be greater than what? 41. Or what someone can do is to say which Tn, which first term, we need n, will be greater than what? 41. Then you can just solve that inequality. So where there is 2n, you can substitute by 2n minus 1 greater than what? 41. Then you can take your n to the other side, your 1 to the other side. Then it will be 41 plus 1. It will be what? 42. Then we divide by 2. We divide by 2. And n must be greater than 42 divided by 2. You can use your calculator just to be safe, right? Remember, this is the final examination. You don't want to make any mistake. Don't use your brain. Just punch a calculator, even though it's quite simple. Then 42 divided by 2, it's giving me 21. So this is not the final answer. Let's be clear. Which first term will be greater than 41? That's what the question wants, right? So it's when n is greater than 21. Which first term is there when n is greater than 21? It's when n is equal to 22. So when n is equal to 22, then we'll have a first term that will be greater than 41. Okay. Okay, let's now look to number 5. Is it number 5? It's number 4. I'm in figure 4. So they say determine the sum of the first n terms, right? Determine the sum of the first n terms. Let's take a look at our sequence. Is it arithmetic or geometric? It's arithmetic. So what is the sum for arithmetic? So it's IV. So the sum of arithmetic, we've already proven it in during this lesson. It says n over 2 2a plus n minus 1d, right? So we need the sum of n terms. They didn't tell us how many terms are there, so when on our n we'll just leave it like that. But we know it will be 2 times a. Our a is our first term, which we already know. Our first term is what? Is 3. That one we can substitute. Our n we don't know because they didn't tell us how many terms. Common difference, we already calculated the common difference to be 2. Then we can just simplify our equation. It will be n over 2 into 2 times 3 is 6 plus 2 times n 2n, 2 times minus 1 minus 2. Then my Sn to be n over 2 into 6 minus 2 is 4, right? So it will be 2n plus 4. Then I can just leave it there or simplify further to say this term multiplied by this one. So 2n multiplied by n, it will be 2n squared, but we are dividing by 2. Then it will be 4 multiplied by n, it will be 4n, but there is divided by 2. Then I can just write it in a simplified manner. 2 and 2 cancel each other. Then it's n squared. My Sn, it will be n squared. 4 divided by 2 is how much? Is 2. So plus 2n. So this will be the sum of the first n terms. It's n squared plus 2n. Okay, let's now look at number 5. They say hence calculate the sum of the first 40 terms. Hence calculate the sum of the first 40 terms, right? So we already determined, if a question says hence, right, it's simply saying your answer that you got in the previous question should help you to get this answer that is being asked in this question. So whenever you see hence, they're saying you must make a relation between your answer you got in the previous question to calculate this one. So we already know that Sn is equal to n squared plus 2n. But now we need the sum of the first 40 terms. So where there is n, we are adding 40 terms. We need sum of the first 40 terms. So where there is n, we just put 40 squared plus 2 into 40. 40 squared plus 2 into 40. Then we can just use our calculator to get the answer. Then it's giving me 1680. So that will be the sum of our first 40 terms. Okay. Okay, grade 12s, we're still on arithmetic sequence and we want to solve this question. They say how many terms of the series 3 plus 8 plus 13 plus to infinity must be added to give the sum of 2265. How many terms? What do they need? How many terms? It means they need what? They need n. But how many terms must be added to give the sum of what? 2265. So we already know the sum is equal to 2265. But we want to know how many terms must be added together to get that sum, right? What is the formula for sum? So the formula for sum is n over 2 because this is an arithmetic series. It's n over 2 2a plus what? N minus 1d. Then must be equal to 2265. So from that formula, we don't know n, we want to solve n, but we know a is our first term, which is what? Which is 3. So where there is a, you can just substitute by what? By 3 plus n minus 1. Let's go and calculate the common difference. We say the second term minus the previous term. Let me just do it on top. Then it will be 8 minus 3 is giving me 5. 13 minus 8 is also giving me what? 5. It means the common difference would be 5. Then equated to 2265. Then you can just simplify there and to solve this. Let me quickly simplify. Okay, when you simplify, you get something like that. Then we have 6 minus 5, we have to write it. 6 minus 5, it will give us 1, so we have 5n plus 1 is equal to 2265. Then we can just remove by n over 2, so it will be n multiplied by 5n, it's 5n squared, but there is divide by 2, plus n multiplied by 1, it will be n, but divide by 2, then equated to 2265, right? So equated to 2265. We can just take our 2265 to the other side, then it will be 5n squared over 2 plus n over 2 minus 2265, so equated to 0. So now our equation is in a quadratic formula manner. We can use a quadratic formula. Don't even stress yourself trying to factorize this thing. Go straight, use the quadratic formula and get your answer, right? So from the quadratic formula, we can say our n is equal to what? Minus b plus or minus root of b squared minus 4ac over 2a. Then we just substitute those things in our quadratic formula. Then we see n equals to minus b. Our b is the coefficient of n, so it's 1 over 2 there. So it's minus into 1 over 2 plus or minus root of our b is 1 over 2 squared minus 4. Our a is the coefficient of n squared, which is 5 over 2. 5 over 2. Then our c is the constant term, which is 22 minus 2265, right? Minus 2265. All those things divided by 2 into our a, coefficient of n squared, 5 over 2. Then we can solve for n. Punch your calculator, then get the value of what? Of n. Okay, when I punch my calculator, my n is giving me 30, or my n is giving me, let me see again, n equals to 30, or n is equal to probably something with a negative number, minus 151 over 5, right? But we know that n is always an element of natural numbers, so it cannot be this answer. So this one is not applicable. So our n is equals to what? Is equal to 30. So that's how you do it. Okay. Okay, now let us consider a different type of an arithmetic sequence. The following is an arithmetic sequence. You are given 1 minus k, 2k minus 3, and k plus 5. Then the first question says calculate the value of k, right? So sometimes they might use k, they might use x, any letter they might like to use. Now you are given your arithmetic sequence not in terms of natural numbers, but in terms of unknowns. There are some sort of unknowns in your arithmetic sequence. How do you do that? How do you solve it? So in order to solve it, what you have to know is what is similar, what is equal in an arithmetic sequence, what is congruent in an arithmetic sequence. We know that what is equal is the common difference. That's why it's called common difference. So the difference is common, is the same in an arithmetic sequence. So what you do if you are given a sequence like this, you go and equate the differences because they are common. So what you do to solve the first one there, it's to solve it, I'm going to say term 2 minus term 1. I know that the first difference there is equal to the other difference that side as we move term 3 minus term 2. So the difference are common, right? So that's what we know. So you got term 2 is what? Is 2k minus 3. Minus, very important. Most of the students, when they come to this step, they just like to say minus 1 minus k. It's wrong, right? So when you have a minus, they ensure that whatever you write, you put it in a bracket so that you make no mistake of removing by negative, right? So minus 1 minus k, I'll just put it in brackets. Then let's go to term 3, it's k plus 5. My term 3 is k plus 5 minus into remember, we have to put in brackets just to avoid, so that we may not make mistake. Minus our term 2, which is 2k, minus 3, right? Then now we can remove by negative, then we'll just have 2k minus 3, negative times 1 minus 1, negative times negative k, it's giving us positive k. So very important. So k plus 5, then negative times 2k, it will be minus 2k, negative times negative 3, giving me positive what? Positive 3. Then now I can arrange like terms together and just add them. So it's 2k plus 2k, it's going to give me 3k this side. Minus 3 minus 1 is just going to give me minus 4, is equals to k plus minus 2k, it will give us minus k. Then 5 plus 3 giving us what? Giving us 8. Then we just transpose and group the like terms. So it will be 3k plus what? Plus k is equals to, we have 8 this side. When we transpose minus 4, it will be positive 4 that side. So we have 4k is equals to 12, because 8 plus 4 is 12. 4k is equal to 12. Then we can divide both sides by 4 in order to solve for k. So our k will be equals to 12 divided by 4, which is what? Our k will be equals to 3. Our k is 3. Okay. Okay, let's now look at the second question. It says write down the value of a and d. We know that a, it's what? It's okay, my mic was far. So it says write down the value of a and d. We know that a is our first term and d is our it's our common difference. So in order to get the value of a and d, what we have to do, we substitute the value of k that we got on our equation. Then we can just get the value of a and d there. So let's go and substitute our k as 3, so that we may have those terms to be 1 minus 3, 1 minus 3. Then on that side it will be 2 into 3. Remember our k is 3. 2 into, okay, this pen here, 2 into 3 minus 3. Then that side it will be 3 plus 1 plus 5. 3 plus 5. So 1 minus 3 is minus 2. Then 2 times 3, 6, minus 3 is 3. Then 3 plus 5 is going to give me what? 8. Why am I writing 5? It's 8. It's 8. Then I can get the value of a. Very simple. A is our first term. It's minus 2. Then my d is the common difference. Term 2 minus term 1. Then is 3 minus. Be very careful of the sign there. So because you just put the other term inside the brackets into minus 2. Because most of the students will just say 3 minus 2. Then they say 1 is the common difference. So it's, be very careful of the sign, especially when your terms have negatives and all that. So ensure that you put them in brackets. So it's 3 minus into minus 2. Then it will be 3, negative and negative, positive 2. Then my common difference is what? Is 5. So that is your value of a and your value of d. Okay. Okay, let's now look at a geometric sequence. All right. So we were doing arithmetic sequence, but now we want to focus on what? On geometric sequence. Okay, just to give you just some hints, or just a little bit of revision on geometric sequence. Geometric sequence is a sequence of numbers whereby the next term is determined by multiplying the previous term with a common ratio, something that is called R. So we multiply the previous term with a common ratio in order to get the next term. But then it's quite different to arithmetic, very different, not quite different, very different to arithmetic, because in arithmetic we add the common difference to the previous to get the next one. With geometric sequence, we multiply the previous term with a common ratio in order to get the next term. Right? So let's just quickly look at this example and see what happens now. there's a given 16 into x minus 2 exponent 3 plus 8 into x minus 2 exponent 4 plus 4 into x minus 2 exponent 5 plus to infinity as a geometric sequence where x must not be equal to 2. So this is a geometric sequence with that restriction x must not be equal to 2 because it won't be valid. So now they say determine the general term of the series in terms of x. You are determining now the general term of this series in terms of x. Let me just write, where should I write? Let me just write here. Determine the general term of the series in terms of x. Now, what is the general term of a geometric series? The general term is Tn is equal to a into r exponent n minus 1. So that is the general term of an geometric sequence, right? So our a is the first term. What is our first term then? So our first term is what? Is 16, okay, to be 16 into x minus 2 exponent what? 3, right? Open brackets. What is our r? R is the common ratio. And how do we get r? We say the following term divided by the previous term, right? So what is our following term? Term 2 there, it's 8 into x minus 2 exponent 4 divided by what is our term 1? It's 16 into x minus 2 exponent 3. So 8 divided by 16 will just give us 1 over 2. Then we are saying x minus 2 exponent 4 divided by x minus 2 exponent 3. It will just be 4 minus 3. Then you will be left with just x minus 2, right? Exponent 1, obviously. So that is our r. So we can write it properly to say x minus 2 divided by 2. So this is the common ratio. Okay. Okay, so our r is x minus 2 over 2. We can just substitute it there, x minus 2 divided by 2 to the exponent of n, sorry about this, n minus 1 to the exponent of n minus 1. Let me just write it properly. Let me delete this r here so that it might not mess up our things. So it's 16. I can just leave it like that because they say write the general term of the series in terms of x. So that's it. So it's 16 into x minus 2 exponent 3, then into x minus 2 over 2 exponent n minus 1. Okay. Okay, let's now look at the second question. They say calculate the value of x for which the sequence is convergence. Very important question. And most of the time in your final examination, this question is always there. Sometimes they might just say, is this sequence convergent or divergent? You must know about this concept, convergent, because this question is always there. 3 free marks, right? So calculate the value of x for which the sequence is convergent. How do we know that our geometric sequence is convergent? It is when our r is between minus 1 and 1. When r is between minus 1 and 1, our sequence is convergent, right? So that's the first statement, and it has 1 mark for just writing that. Oh, let me just close it. It has 1 mark for writing that. So it's when r is between minus 1 and 1. So we already calculated r, right? Our r was what? X minus 2 divided by 2 must be between minus 1 and 1. Then you just solve for x, then you would have determined the value of x for which the sequence is convergent. How will we solve for x? Let's multiply by 2 both sides, right? When we multiply by 2, it will be minus 2. That's x minus 2. That 2 multiplied by 2 cancel out each other. Then this side 2 times 1, it will be 2, right? Then we can transpose, right? Or add the additive inverse both sides, right? So in order to cancel that minus 2 inside, what must we do? We must add 2. So when we add 2 in the middle, we have to add it also on both sides. So it will be minus 2 plus 2 less than x minus 2 plus 2 less than 2. Okay, space. Okay, let me just say 2 plus 2. just be very short today, sorry for that. And let's just simplify it, then we'll be left with x there, because we are saying minus 2 plus 2, they cancel each other, it's 0. Then we're left with x less than minus 2 plus 2, it's 0. Then 2 plus 2 is 4. So the values of x that will ensure that this series becomes convergent, it's when x is between 0 and 4. So that's what you do. You just need to know that our r must be between minus 1 and 1, then solve for x. Okay, let's now look at the last question. They said determine the sum to infinity of the series if x is equal to 2, 5. Determine the sum to infinity of this series. Okay, what's the formula for sum to infinity? Sum to infinity, and that's the symbol for infinity, is equal to a over 1 minus r. So you must have your a, you must have your r. So our a now from our series is 16 into x minus 2 exponent 3. But when x is equal to 2.5, we have to substitute there. Our s is 2.5 minus 2 exponent 3. So it's 2.5 minus 2, 2.5 minus 2 exponent 3, then multiply by 16 like that there. Let me just use my calculator, then it's giving me an answer of 2. So our a is 2. Then our r, we had already represented r in terms of x. We had x over 2, x minus 2 over 2, but my x is 2.5. I replace by 2.5 minus 2 over 2. Then my r will be 2.5 minus 2 divided by 2, which is giving me 1 over 4. So my r is 1 over 4. Then I can just go to my formula and replace and get my sum to infinity. I can get my sum to infinity. Okay, let me go and replace. I will say sum to infinity is equals to my a, which is 2 over 1 minus 1 over 4. 1 minus 1 over 4. Always ensure that after a negative, put the following thing inside the bracket to avoid making those silly mistakes. So let's see. Then using my calculator, I'm getting the sum of infinity to be 8 over 3. 8 over 3 will be the answer for our sum to infinity. Okay. Okay, let's now look at this other question. We are still on geometric sequence, and it says given 2 and minus 1 as the first two terms of an infinite geometric series. So infinite, it means it's going to infinity. There is no last term, right? We have 2 and we have minus 1. Then our sequence is just going like that. There's no last term. So calculate the sum of the series. It's quite a simple question. So we know the formula for sum of infinity, because this is sum to infinity, right? It's sum to infinity because we have infinite terms. We don't know where they are ending. It's just going to infinity. So it's sum to infinity. Then we just say a over 1 minus r, right? What is our a? Our a is 2. What is our r? Second term divided by the previous term. So it will be minus 1 over 2, right? So our a will replace with 2, 1 minus. Remember, after a minus, always put your thing in brackets to avoid making mistake. Minus 1 over 2, we put it like that. So a lot of students make this common mistake. They must say 2 over 1 minus 1 over 2. Then it's wrong, you see. So that's why after a negative, always ensure that what's following is inside the bracket, so that you may not make any mistake. So it's basically 2 over 1 plus, because negative and negative is plus, so plus 1 over what? 1 over 2. So we'll say 2 over 1 plus 1 over 2. Then using our calculator, we just get the answer. Our answer is 4 over 3. So 4 over 3 will be the sum of this series. Okay. Okay. Let's now move and talk about combination, right? Um, uh, it's not a new section, it's just number patterns, but now we are dealing with a combination of maybe arithmetic and geometric sequence in the same sequence, right? So in this question, what you have to notice is that if you are just given a sequence and they don't tell you whether it's arithmetic, geometric, or quadratic, what you do, you first check whether it's arithmetic. How do you check that? You calculate the common difference. If there's a common difference, then it's arithmetic. If there's no common difference, you now calculate what? Ratio, right? If the ratio is also common, there's common ratio, then it's geometric. But if there's no common ratio, you then calculate what? You then check whether there will be the second difference that will be equal. Then that's just quadratic that we'll focus on later. Then also, if that's not the case, you now check whether now is it a combination of arithmetic or geometric. Normally they don't tell you that it's combined, they just give you, they just want you to think like that. So if you find that no, my sequence is not arithmetic, it's not geometric, it's not quadratic, then you have to check whether it's combination. How do you check? So with a combination of arithmetic and geometric sometimes, but now I'll just focus on one aspect, that is combination of arithmetic and a constant sequence, right? Arithmetic and a constant sequence. How do you know? You just check now. Okay, I see in between there is like a constant sequence, like there are constant values, then outside they're like sequence. So it's either they start with arithmetic then geometric, or they can start with constant sequence, arithmetic, arithmetic, like that, like in this case. So in this case you can see that there are constant sequence in between, which are the twos, right? I'll just represent it using the other color here. It's 2 2 2. There are constant sequence in between. Then there is the sequence itself here, 3 6 9. It's the sequence. So they started with what? With the arithmetic sequence, then constant term, arithmetic sequence, constant term, arithmetic sequence, then what? Constant term, right? So that's how it is. So the first question says write down the next two terms. It's I. Write down the next two terms of the sequence. Then we can see after 2, which is our constant sequence, what's coming next? What's come next is our arithmetic term, right? So let's first get the common difference of our arithmetic term. We know it's 3 6 9. The common difference, 6 minus 3 is 3, 9 minus 6 is also 3, so the common difference is 3. So to get the next term on an arithmetic sequence, we add the common difference of 3. So it will be 9 plus 3, then it will give me what? It will give me 12, right? It will give me 12. So what will be the next two terms? What's next there is 12, then what? Then a common, a constant sequence, then 2. So our next term is 12, then 2. These are our next two terms. Okay. Okay, let's now look at the second question now. Calculate the sum of the first 100 terms of the sequence. The sum of the first 100 terms. So this is a little bit of a tricky question where most students can just make a mistake, but we are sure after this video you won't make that mistake. So let's just see how you can do this. So now if you want to calculate the sum of the first 100 terms, what you have to do is you have to make sure that you accommodate for all those constant term and arithmetic term. Remember, in those 100 terms of yours that you want to get the sum, there are constant terms and there is also arithmetic terms, right? So then sum of 100 terms, it just be splitted into 2, because we have two kind of sequence there. We have the sum of the first 50 terms, we can call it this one for arithmetic, then another sum of the first 50 terms of what? Of constant terms, right? So with the one for arithmetic, we can use a formula n over 2 into there's this formula a let me just use the common one, 2a plus n minus 1 d, then plus sum of the first 50 terms of is it of constant terms? It's 2 2 2 2 2. We are adding those 2's, right? So we can just say how many numbers of those constant terms are there, multiply by them, right? Multiply by 2. Number of those 2's multiply by 2 to get their sum. So I'm just going to substitute there. My n, because I'm saying 50 will form arithmetic, n is what? Is 50. So it's 50 divided by 2 into 2 times. What is my a on my arithmetic? My a is what? Is 3. It's 3. And into n is 50. 50 minus 1 multiplied by the common difference. I think we already calculated it to be 3, right? The common difference was 3 there. It was 3. Then plus, and this side, number of constant term, remember there are 50 of them, 52's, right? So it will be like 50 times 2, their sum. Then we can just use a calculator straight away. Then we just get the answer. 50 over 2 into 2 times 3 plus 50 minus 1 multiplied by 3 plus 50 times 2. And then we can just get the answer. It's giving me 3,925 as the sum of the first 100 terms. So be careful this side when you need sum of the first 100. Remember, if it's combination, so you have the 50 for arithmetic, you have the 50 for constant term, you have to accommodate the two together. 50 plus 50, they form 100 terms, right? So we get that answer there. Okay. Okay, let's now move to the last one. They say calculate the sum of the first 45 terms of the sequence. 45 terms. Now, if you check the terms that you are given, it's 45. It's not like 100 like the previous question where you just split it into, okay, 50 is constant terms, 50 is those for arithmetic. Now it's 45, right? It's 45. It's not an even number, right? So you can't say you divide by 2 because you'll have some numbers with a comma. So it means that there is one sequence that will have more terms than the other, right? So that's it, right? So let's see. Okay, if they'd said calculate the sum of the first 5 terms, right? 5 terms. Let's just use 5 so that you can understand how would reach a conclusion with 45. If they say calculate the sum of the first 5 terms, we're just gonna say, let me show you here, the sum of the first 5 terms, maybe probably a different color. It's 1, 2, 3, 4, 5. It's this one. 1, 2, 3, 4, 5. Sum of the first 5 terms. Okay, we are just using an odd number so that you can see how we can get also this if there is combination. Sum of the first 5 terms. We were going to count how many arithmetic terms are there. We only have 1, 2, 3 arithmetic terms, right? But then the constant terms are 2. You can see that the arithmetic terms will be more by 1 as compared to the constant terms, right? Why is it like that? Because we are starting with the arithmetic sequence. Then obviously when we end with an even number, we are also going to end with an arithmetic sequence. That's why there will be more than those constant terms. So now in 45, what can you see? How many arithmetic sequence are there? We know that what is more is the arithmetic sequence. So how many arithmetic sequence are there in 45, right? So we can actually check. If we divide 45 by 2, it's giving me 22.5, right? So probably we have 22 plus 23 terms because we said one will be more than one, right? So the one that has 23 terms will be for what? For arithmetic. We have seen that it's an even number. The one with more is arithmetic. Then 22 terms will be the one for constant. You see how you get it. So that's basically how you can do it, or any approach that you can use so long as you reach that final conclusion. that okay, in this one, if we have 45 terms, 23 terms are arithmetic, then 22 terms are what? Are uh, 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 constant terms, like that. So we can now calculate. So sum of the first 45, it will be the sum of the first 45, it will be the sum of the 23 which are arithmetic plus the sum of the 22 which are what? Constant, right? So sum of arithmetic 23 is 23 of them, it will be 23 over 2 into 2 times, we are just using the sum formula. I won't write it again, I'm just substituting. 2 times our a is 3 plus our n is 23 minus 1 times our common difference we already calculated as 3 plus sum of the first 22 of constant terms. So it's those 2's that are how many of them? 22. So their sums will be their number, which is 22 multiplied by 2. Then we just get the sum of those 2's that are 22. So I'm just going to use a calculator quickly. 23 over 2, 2 times 3 plus 23 minus 1 times 3 minus 1 times 3, then plus 22 times 2, then I'm going to get an answer is 872. 872. So that will be the sum of the first 45 terms. So this is basically how you calculate if you have combination of sequence, right? So just know if you have combination, if you have an even number, you get the sum. If it's like 100 like we did, we just divide into 2. There are 50 constant, there are 50 arithmetic, like that. Sometimes it can be a combination of arithmetic and geometric, and they won't tell you. So in that case, you just go and check. Okay, let me say the first term is arithmetic, the second geometric, arithmetic, geometry, arithmetic, geometry. You check like that, then you calculate the common ratios. In those one that you said is geometric, calculate the common difference. In those one that you said is arithmetic, then after calculating like that, you now check, okay, now I now know this one is arithmetic, this one is geometric. Then it will be very easy to calculate these other questions such as sum of what, right? Okay, yeah. Okay, let's now look at combination, another problem. They said given the sequence for x 32, then determine the values of x if the sequence is arithmetic, right? So in this case, it's sort of like combination, but it's not really that combination that it's like they're combined. It's just that, okay, they want to treat it as arithmetic first, then they also want to treat it as what? As geometric. Then they are saying calculate the values of x. Okay, in order to do that, we're just gonna start with I, the one for arithmetic. Determine the value of x. How do we do that? We know arithmetic sequence, there is common difference, right? You equate the difference. So it's term 2 minus the previous term must be the same as term 3 minus the previous term, which is term 2, right? So my term 2 is x minus, I said always when you put minus, just put it in brackets so that you may not make any mistake, right? So minus into what? Into 4 is equal to term 3 is 32 minus open brackets x. We just want to be sure. Remember, this is grade 12 and you don't want to make those silly mistakes that can cost you a lot of marks. So now we can transpose, or we can remove by negative just to write it properly. X minus 4 is equals to 32 minus x. Then we can transpose and group the like terms, right? X that side to be x plus x will give us what? 2x, right? 2x is equals to 32 plus 4, it will give me what? 36. Then to solve for x, I divide by 2, then 2 cancel 2, then my x will be equals to 36 divided by 2. Let me just use a calculator. Remember, we don't want to make any mistake this time. We're at grade 12. Let's just punch a calculator. Even though it's simple, punch a calculator. Then x will give us what? 18. So when it's arithmetic sequence, x is equal to 18. Okay. Okay, let's now look at when it is a geometric sequence. So if it's a geometric sequence, we know something that is common is the ratio. So how do you get the ratio? Second term divided by the previous term, third term divided by its previous term. Then you equate like that, you solve for x. So term number 2 is x divided by term number 1 is 4, then term number 3 is 32, then term number 2 is x. So to solve for x there, we're just gonna cross multiply. X multiplied by x, it will give me what? X squared, right? It's x squared is equal to 4 multiplied by 32, then 4 multiplied by 32. Let me just write 4 multiplied by 32. Then I'm just gonna solve for x there. So it will be x squared is equals to 4 multiplied by 32 is 128. Then to solve for x, I'm gonna apply the square root, right? So x will be plus or minus root 128. So x will be plus or minus root 128. Then it's giving me plus or minus 8 root 2. So our x is plus or minus 8 root 2. So when the sequence is geometric. So what's very important here is that you must know when it's geometric, you equate the common ratio. Then when it is arithmetic, you equate the difference. So you have something like this for arithmetic, then for geometric you equate its ratios, then you just cross multiply, solve for the unknown. That's it. Okay. Okay, let's now focus on the quadratic sequence. The quadratic sequence, and let's start with this example. They say given the quadratic sequence 5, 7, 13, 23 to infinity like that, write down the next two terms of the sequence. Write down the next two terms, right? Okay, so we have our quadratic sequence is 5, we have 7, we have 13, and we have 23, right? So in a quadratic sequence, what you have to know, there is the first difference and there's also what? The second common difference, right? Because the first difference forms a linear sequence, then we know from a linear sequence we have the common difference. That's why the second difference is common. So let's go and get those difference. 7 minus 5, it will give us 2, right? So 13 minus 7, it will give us, is it 6? Let's check. 13 minus 7, it's 6. Okay. Then 23 minus 13, it is giving me what? 10, right? So those are the first difference. Second difference, 6 minus 2, it's 4. 10 minus 6 is also 4, right? So you can see the second common difference are equal. They are common, right? Yeah. So how do we get the next two terms in a quadratic sequence? What you do is that you extend also again 2 times because you need 2 terms, right? But we know the second common difference will always remain what? 4. They will always remain 4. 10 plus 4 is 14, right? Then we can get the next term on top there because we just got the next term on the linear sequence. So we can say 23 plus 14, then we can get the answer for the next term there. It's giving me 37. Okay, then we say 14 plus 4, it will give us what? 18, right? Then to get the next term, we say 37. Remember we have 37 there, plus what? Plus 18. So we get the next second term there. I mean the next term, because 2 of them, so it will give us 55. So the next two terms we can see is 37 and what? And 55. Let me just put them there so that we can see them. So it's 37 and 55. So that's basically how we calculate the next two terms in a quadratic sequence. Okay, let's move to the second question. It says calculate the nth term of the quadratic sequence. Calculate the nth term. So what is the nth term of a quadratic sequence? We know that Tn is equals to what? An squared plus Bn plus C, right? So you have to get A, B, and C, right? But we know there are formulas that we can use to get all those things. For A, we take what? The second difference and divide by 2, right? For A, to get A, we say second difference divide by 2. Let me not just write it like this. Let me write it properly to say to get A, we say second difference divided by 2. So what is our second difference? Our second difference is 4, just be 4 divided by 2, which will give us 2. That is our A. Our A is equal to 2. Okay, now that we got our A being equal to 2, we can go and calculate our B, right? You know that you just say 3A plus B is equal to term 2 minus term 1, which is 2, right? So you're going to say 3 into your A was 2 plus B will be equated to 2, which is term 2 minus term 1. Then we can solve for B there. Let me just delete this formula so that we can solve for B. Then we know we're going to say 3 times 2 is 6 plus B is equal to 2. Then our B will be 2 minus 6, which is negative 4. So let me put it there. B is equal to negative 4. So that's how you calculate B. You say 3A plus B equals to term 2 minus term 1. Then you calculate B. Okay, for C, we say, okay, let me delete these ones. For C, we come and say A plus B plus C is equal to term number 1. A plus B plus C is equals to term 1. Then we calculate C. We already know our A is 2, our B is minus 4, plus C is equals to our term number 1 is 5. Our term number 1 is 5. Then we can solve for C. 2 minus 4 is negative 2, plus C is equals to 5. Then our C will be 5 plus 2. When we transport negative 2, then C will be equals to 7. So our C is equal to 7. Remember, don't forget to show all your workings on your paper whilst writing. Okay, then now we can write our Tn because we have A, B, and C. So our general formula will be Tn is equal to our A is 2n squared minus 4n minus 4n plus 7. So that is our nth term or our general formula. Okay, let's now move to the next question. We're gonna focus on this question. Roman figure 3, it says determine the 10th term of the above sequence. So they just need term number 10. So where there is n, we are going to replace by 10 to get our term number 10. So it will be 2 into 10 squared minus 4 into 10 plus 7 plus 7. Then we just use a calculator. 2 into 10 squared minus 4 into 10 plus 7, then it's gonna give me term number 10 is 167. So this is our term 10. Okay, Roman figure 4, then the question says which term in the sequence is equal to 55? Which term in the sequence is equal to 55? So they need the number of term, they need n, right? So because they need n, we're gonna say which term in the sequence, the nth term, that is equals to what? 55. We're just gonna equate Tn to 55 and solve for n. So we're gonna say our Tn, we calculated it as 2n squared minus 4n plus 7, then equated to 55. Then it's 2n squared minus 4n plus 7. Take 55, transpose it to the left hand side, and it's minus 55 is equals to 0. Then it's 2n squared minus 4n, then 7 minus 55, it's going to give me minus 48 is equal to 0. Then we can just use a quadratic formula to solve that. So using the quadratic formula, we'll get our n being equal to 6, or n being equal to, let's check here, because of space I can't write the quadratic formula. Then you just have to write it in if you're answering such kind of question. Then n equals to 6 or n equals to -4, but we know that n must always be an element of a natural number. N must be an element of a natural number. So if it's negative, then we don't consider it, we take only 6. So which term will be equals to 55? Is term number 6. Is when n is equal to 6, is term number 6. Okay, let's continue with this question. It's Roman figure 5. Quite a challenging question. Sometimes it comes with around 4 or 5 marks, sometimes 6. So it says, determine between which two consecutive terms in the quadratic sequence the first difference will be 2018, right? So between which two consecutive terms in your what? In your quadratic sequence will the first difference be equal to 2018? Okay, in order to answer this question, I still remember when I was in grade 12, you have to try to simplify the question for yourself, right, in order to answer it. So you ask yourself a simple question and you use that simple question to get the answer of this kind of complex question. So this is what I did. I said, okay, what if the question says between which two consecutive terms will the first difference be 2, right? Will the first difference be 2? Look at 2 there. Between which two consecutive terms? I already know them. It's between 5 and 7. But they're standing on which position? It's on the first position and on the second position, right? But our first difference that is forming, it's standing on what? On the first position. It means that the first difference that is standing on position number 1 will be formed by term 1 and the following one, which is term 2 on the quadratic sequence. Let me repeat that. It means that the first difference on our quadratic sequence that is standing on position number 1 will be formed by term 1 and the following one, which is term 2. Okay, let's move to 6. Let's move to this first difference of 6. If you check, the first difference of 6 is standing on position number 2 of our first differences, right? It's standing on position 2. And we can see that it is formed by term 2 and the following one, which is term 3, right? So now it is now easy to answer this question. Between which two consecutive terms will the quadratic sequence of the quadratic sequence they will form this first difference of 2018. So if we get the position of this first difference, we can conclude that, okay, it is between this term and the following one, right? That's how we do it. So let us go and get the position of this first difference. So this first difference form part of a linear sequence, which is Tn is equals to a plus n minus 1 d, right? So our Tn, we want to know which position is 2018 standing at. So we put 2018 at Tn, and then our a, our first term in our first difference. Don't forget we are using first difference because 2018 is a first difference. So our a is 2 plus n minus 1. Our difference, we have already calculated them. They are 4. Then we are going to solve for n, right? Okay, so when we solve for n, you'll find that your n is going to be equal to, when you solve, you take 2 that side, divide by 4, you add 1. Then it's going to give us 505, right? It means that 2018 is standing on position 505 on our first difference. Then we can conclude, therefore, which two consecutive terms that will form that 2018. Okay, because it's standing on position 505, then on the quadratic sequence it was formed by term 505 and term, the next term, 506. So it is between term 505 and term 506. So that's it. Okay, let's now move to the last question. It says, what is the value of the first term of the sequence that is greater than 77? So this is also a challenging question because students mostly make mistakes while answering this question. But what you know is that you want the value of the first term, right? That will be greater than what? Than 77. That is greater than 77. So we need to determine the value of the first term. That will be first term of the sequence. What is the value of the first term of the sequence? That will be greater than 77, right? So we already know Tn. Our Tn is equal to 2n squared minus 4n plus 7. So we need that first term that will be greater than 77. Let's first determine its position, that term that is greater than 77. So we need when our Tn is greater than 77. Therefore, we can calculate the what? Its position. After getting its position, which is our n, then we can go back and substitute and get that value, right? So our Tn must be greater than 77, but we know our Tn is 2n squared minus 4n plus 7 must be greater than 77. So then it will be 2n squared minus 4n plus 7. We transpose 77 to the other side to be minus 77 must be greater than 0, right? So we can just write it properly. It's 2n squared minus 4n. 7 minus 77 is minus 70, must be greater than 0. Then we can just now use what we learned in algebra in the other video for the this revision series, how you can factorize and do all those things in order to get those values. So let's get our critical values, then we can just check the direction where they will be pointing, right? Okay, I quickly used the formula for quadratic sequence, quadratic formula in order to get my critical values. Then I got my critical value as 7 and the other critical value using the quadratic formula, I'm getting it as minus 5, right? So this is a quadratic graph and our a is positive, therefore it's a smile, just as you learned in algebra there, it's a smile. Therefore, we're going to look where the graph is above 0. So we said the line stands for 0. Then above 0 will be on top, right? So it will be on top this side and also this side. So we can conclude it's when n is less than minus 5 or n is greater than what? Than 7. But we know n is the element of natural numbers, so it cannot be negative. We cancel out that one. So it's when n is greater than what? Than 7. But we haven't answered the question, right? Remember, the question needs the value of the first term that will be greater than 77. So So this value of the first term is standing on a position when n is greater than 7. Therefore, we can conclude that it is standing on position number 8, right? Because it's standing on position when n is greater than 7. And what is the next value there when n is greater than 7? Is what? It's 8. So it's standing on position 8. Therefore, we can say n is equal to 8, right? So this is just the position. It's not the value of that first term, right? That is greater than 77. We just calculated its position. It's when n is equals to 8, right? So because it's when n is greater than 7 and the next value is 8. So we can quickly go to our quadratic formula and calculate term number 8, because it's that value of the first term when the sequence is greater than 77. So we just substitute our 8 as our n in our quadratic formula, then we get the answer. I mean, in our quadratic sequence equation or general formula, then we can get the answer. So our term 8 is equal to 103. So 103 is the term that will ensure that our quadratic sequence will be like greater than 77, right? So our T8 is 103. So be very careful when answering this question. Just read them thoroughly so that you may not make any mistake or end without completing all questions. So be very careful when answering them. Okay. Okay, so we are still on quadratic sequence. I guess this is the last example that I just want us today to focus on, so that you may be fully prepared to answer any quadratic question that might be examined in your final examination. Remember, we are still doing the maths revision series, and we are on number pattern. So let's look at this question. It says the quadratic pattern minus 3, 4x and 30 to infinity is given. So determine the value of x, right? So this is a quadratic sequence, and that is a very key statement and keyword that will direct us. So what do we know about quadratic sequence is that there is first difference and there is second difference. But what we know also is that the second difference are common, they are equal, right? So what we have to do is we're gonna get the first difference. Let me just write this sequence properly here. Then x, then 30. Then I'm going to get the first difference and also the second difference, because the second difference are common. Once I equate the second difference, I can be able to solve for x. So we say 4 minus the second term minus the previous term. I told you that immediately when you have minus, put everything that follows in the bracket so that you may not make mistake. So in this case, if we want to get our difference, we'll say x minus, open brackets, the previous one, which is 4. In this one, we'll say 30 minus, open brackets, which is x, right? So we can just simplify them. 4 minus minus 3 using a calculator to give me 4 plus 3, which is 7. So I can just delete that and put my 7. Just wanted to show you how we got there. X minus into positive 4, it will just be x minus 4. So I can just remove the brackets there, and it will be x minus 4. Then 30 minus into positive x, it will be 30 minus x. So it's 30 minus x. Let me just write it properly there, 30 minus x. So those are our first difference, right? We need to get the second difference. So to get the second difference, you take the following term, you subtract the previous term. So it's x minus 4 minus into 7. Then this side, it will be 30 minus x minus into x minus 4, right? So let's simplify that. It will be x minus 4 minus into 7. to be minus 4 minus 7, which is minus 11, right? So this is our our second common difference. It's our second common difference. It's correct. So this side, it will be 30 minus x. We remove the brackets by negative. It's minus x again, negative and negative 4. So it will be positive 4. So minus x is minus 2x. 30 plus 4, it will give me 34. So make sure that you do those things very carefully, because you don't want to lose these marks, right? So after getting the second difference, what do we know? Second difference of a quadratic sequence are common, or they are equal, right? So they are equal. So what we do, we just take our second difference and we equate them. So we take x minus 11 is equals to minus 2x plus 34, right? Plus 34. Then we can group the like term together. So you take x, you group it with this 2x this side, then you say 34 minus 11, you transpose it to the other side, it will be plus 11. Then 34 plus 11 is giving me 45. Then x plus 2x is 3x. To solve for x, we're going to divide by 3. We're going to divide by 3. Then our x will be 45 divided by 3, which is 15. So we have solved for x. Let me repeat this. How do we solve for x in a quadratic sequence? Get the first difference, get the second difference, equate your second difference to solve for that unknown. That's it. Okay. Okay, let's now look to this section. It's sigma notation. Sigma notation. So what do we mean by sigma notation? So this is a notation that is used to represent the sum of a series in a simplified or compact or summarized manner. So we call that notation sigma notation, also known as the sum notation. Why do we use it? For example, you might want to represent a series, but that series might be having too many terms, right, in it, maybe till 1000 terms. So you can't just write down all those terms one by one. You will take a lot of time to represent that series, right? So another way to do this, we can use this notation called sigma notation. It will just represent that long big series in a summarized or short or very compact manner, right? So we call that notation sigma notation. So let us look at this example. It says the following geometric series is given: x is equals to 5 plus 15 plus 45 plus up until we reach 20 terms. Write the series in sigma notation. So sigma is this Greek letter E, which is representing sum. So from this Greek letter E, down there you represent your starting point, on top you represent your ending point. So always when they give you this question, write in sigma notation, you always say when n start from 1. You always use that. N start from 1 up until we're ending on 20 terms. So on top will be 20. So n starting from 1 up until we reach how many terms? 20 terms. So that's it. So in the center there, what you put is your general formula, or the nth formula of the series. So because that one is a geometric series, in order to get the general formula, we must have a and r. So our a is the first term, which is 5. Our r is the same as term 2 divided by term 1. Our term 2 is 15 divided by 5. Then it will give us what? 3. So our r is 3. But we know that the general formula for geometric series is a into r exponent n minus 1. So our a is 5, our r is 3 exponent n minus 1. We're just going to put it at the center. Then you would have written that series in sigma notation. So it's 5 into 3 exponent n minus 1. So this is our sigma notation. We have just represented this sum in a short and summarized way. and using this notation called sigma notation. Okay. Okay, let's now focus on this problem. We're still on sigma notation, and we want to evaluate this sum. So it says sum where k start from 0 up until 99, 3k minus 1. So before solving this sum, you must ask yourself, is this sum of arithmetic or is this sum of geometric? How do I know? You look at the general formula, right? You look at the general formula. So if you check your general formula there, right? Our general formula is what? Is linear sequence of what? Of arithmetic. How do we get the sum of arithmetic? We use the formula Sn is equals to what? Sn is equals to n over 2 into what? Into 2a plus n minus 1 d. So this is the formula that we use to calculate the sum of arithmetic sequence, right? Of arithmetic series, by the way. So before calculating, just first determine the first three terms, right? So that you may be able to calculate the common difference. You may also be able to know what is your value of a, right? So we are going to calculate term number 1, term number 2, and term number 3. So term number 1, this is your starting point down here. It is when k is equals to what? Is equals to 0, right? Term number 1 is when k is equals to 0. Your sigma notation is starting when k is equals to 0, right? So it means to get term number 1, we are going to substitute k is equals to what? 0 from our general equation. So then subtract 1, answer will be -1, right? But then if you take a look at so the mistake that most students do here is that when they are required to get term number 1, they just go and substitute 1. No, it's wrong, right? You look, where is my sigma notation starting? It's starting when k is equals to 0. You go and substitute 0, you get the answer. Let's go to term number 2. So with term number 2, from 0 we go to 1, right? We go to 1. So where there is k, we are going to substitute 1 and solve for that thing. Then it will just give us 2, right? So let's go to term number 3. From 1 we go to where? We go to 2. So they ascend in that order. You don't look at these values here, otherwise you'll make mistake. You look at your starting point and you ascend from it to get the other terms, right? So we are going to substitute k2, then solve for it. Then it will give us 5. So those are our first 3 terms, right? Then we can just calculate the sum now. But now we need to get n, number of terms. How many number of terms are there in this sigma notation? Okay, let me just delete this and just maybe use a red color to show how many number of terms are there in that sigma notation. So to get the number of terms, there is a formula, likely. So we say top minus bottom plus 1, right? Top minus bottom plus 1. So what is your top? Your top is 99, right? Minus your bottom value is 0. Then you say plus 1. Then it will be 99 minus 0 is 99 plus 1 to give us what? 100, right? So our n is 100. Then we can get also the common difference, because there's a common difference there. Common difference is equals to the second term minus the previous term. So what is my term 2? My term 2 is 2 minus this term here. I must put it in brackets to avoid making mistakes. So it will be 2 minus into minus 1, then it will be 2 plus 1, which is equals to 3. It's my common difference. Now I have my common difference, which is 3. I have my a, which is my first term, equals to minus 1, and I also have my number of terms, which is equals to what? Which is equals to 100. Then I can just go and substitute to the formula and evaluate my sigma notation, or calculate actually what is the sum of that sigma notation. Okay, I'm going to substitute in my formula. Then I need the sum. Okay, let me just write here, sum of 100 terms. Where there is n, I'm going to put 100 over 2 into 2 times, what is my a? My a is -1 plus my n is 100 minus 1 multiplied by my d, which is 3, then get the answer of that sigma notation. So when I punch my calculator, I'm getting 14,750. Then I know for sure this is the answer for that sigma notation. So that is our answer. So that's basically how we calculate it. So if you are given for geometric sequence, you're just gonna use the sum of geometric sequence, you get your unknowns, then you solve for the sigma notation there. Okay. Okay, so we are still continuing with sigma notation. It's a different problem, and in this problem you are given that calculate the value of n if the sum of where k start from 1, 2 into 3 exponent k minus 1 up until the sum is ending at n is equals to 53 1440. So now you are given the value of your sum, right? So they need you to calculate what? N, how many number of terms are there in the sigma notation. So in your series, how many terms are being added? So if you want to determine this, you must first check, is this sum of arithmetic or sum of geometric? How do I know? Look into the general formula. So check your general formula there is 2 into 3 exponent k minus 1. So it's sum of geometric series. So you must remember the formula for sum of geometric series is Sn equals to a into 1 minus r exponent n over 1 minus r, right? Over 1 minus r. So you can use this formula, or someone can use that other formula that says Sn equals to a into r exponent n minus 1 over r minus 1. So it doesn't matter which formula you use, all of them, they're just gonna give you the same answer, right? So then from this formula, what do we know? We know the sum is equals to 531440. It's so we have the sum there. Do we know the value of a? No, we don't know a, right? So we don't know a. What do? We go and calculate a, right? So our a is equals to term number 1, which in this case is when k start from 1. It's not like the previous example where k started from 0. In this case, our term number 1 is starting, check your starting point there. It's when k start from 1. So where there is k, you're gonna substitute 1 and solve for your term number 1. So it's 2 into 3 exponent 1 minus 1. Then it's 2 into 3 exponent 0. Anything exponent 0 is what? Is 1. Then your term number 1 will be equals to 2, right? So that is your a. Then let us move and go and calculate r. R, we found r by saying the second term divided by the previous term, right? But we don't have term number 2, right? We only have term number 1, which is equals to 2. Let's go also and calculate term number 2, but we must know that term number 2 is when k start from the following one, right? From this one. So here term number 1 is when k started from 1. If we need term number 2, we ascend one step, then it's when k equals to what? Equals to 2. Then you just go there and substitute on your formula 2 into 3 into 2 minus 1. Then it will give you 2 into 3, which is 6. So your term number 2 is 6. Then you have term number 1 is 2, term number 2 is 6. You can substitute 6 divided by 2 to get your r, which will give you 3, right? So your r is 3, your a is 2, and then your Sn we already know is 531440. So let us go and substitute all these values there in order to calculate the value of n. Okay, let's go and substitute. Our sum is 531440. We go and write 531440 is equals to our a is 2 into 1 minus our r is 3 exponent n, because we want to solve for that n, 1 minus 3 because our r is 3, right? So 1 minus 3 is going to give us minus 2, then we cross multiply, right? When you cross by minus 2, we'll multiply with 53,144,0, then being equated to 2 into 1 minus into 3 exponent n. So let's say minus 2 times 53,144,0 is giving me minus 106,288,0. So it's minus 106,288,0 is equal to 2. If I remove by 2, 2 times 1 is 2, then 2 times minus 3 exponent n is going to be minus 2 into 3 exponent what? Exponent n, right? So I'm just going to take the 2 to the other side, then it will be minus 106,288,0 minus 2, then it will be minus 106,228,2 is equals to minus 2 into 3 exponent n. Then I'm going to divide both sides by minus 2. Then this cancel this one, then that one divided by minus 2 is just going to give me, I think I'll just delete some of the stuff here so that we can have some space. Then when we divide by minus 2, I'm getting 53. Let's see, it's 53,144,1 is equal to 3 exponent n. So to solve for n, we can raise this one to the exponent of to the power of 3, right? So if it doesn't allow, then we can use other method. So it allows, so this one is the same as 3 exponent 12 is equals to 3 exponent what? N. Then to solve for n, because the base are the same, we equate the exponent. Don't forget the video on algebra, we equate the exponents. Then our n is equal to 12. Our n is equal to 12. So that's basically how you solve for n given the sigma notation and the sum and the answer for that sigma notation. Okay. Okay, let's now lastly look at the number pattern problems when you are given the sum formula. How do you solve those number pattern problems if you are given what? The sum formula, right? So they said the sum of n terms of the sequence of numbers is given as Sn is equals to n over 2, 5n plus 9. Then the first question says, so the first question it's saying, let me check. So it's saying calculate the first 3 terms, right? Calculate the first 3 terms. Now the mistake that most students do, they just think this is the general formula, right? Then for getting the first 3 terms, just go and substitute S1, S2, S3. Then they say we got our first 3 terms. It's wrong, right? Very wrong. If you are given some formula, you must know how to calculate term 1, term 2, term 3. Not S1, S2, S3. It's not your first 3 terms. But here they need first 3 terms. So they need term 1, term 2, and term 3, right? So there's a standard formula that you can use in order to calculate this if you are given the sum formula. So if you are given the sum formula and you want Tn, you just say Tn is equals to Sn minus Sn minus 1. So this is the formula that you use to calculate the terms given what? The sum formula. If you are given the sum formula, you want to determine the first 3 terms of the sequence, use the formula Tn is equals to Sn minus Sn minus 1, right? But with this one, it's just gonna be what? T1 is gonna be S1 minus, if you say S1 minus 1, you will see like it will be like let me just delete these ones. So it will be like it's S1 minus S1 minus 1 is S0, right? And probably we don't have S0 because our sequence start when n start from 1, right? Because it's the element of natural numbers. So with term number 1, it will just be equals to what? S1. Term number 1 will just be equals to S1. Then if we want term number 2, we are going to say S2 minus S2 minus 1. Then it will be S2 minus S1. So term number 2 will be in that form, S2 minus S1. Remember, we are using the standard formula here for determining terms if we are given some formula. So with term number 3, it will just be what? S3 minus S3 minus 1. So it will be S3 minus S2. S3 minus S2 being your term 3. So that's the standard formula we use. So let's go and determine the first 3 terms of the sequence given the sum formula. Okay, so with term number 1, we said it's just equal to S1, right? So you're gonna calculate your S1 where there is n, you're gonna substitute 1. So it will be 1 over 2 into 5 times 1 plus 9 plus 9. So it will be 1 over 2 into 5 times 1 plus 9. Then it will give us what? 7. So that is my term 1. With term 2 is S2 minus S1, right? So we must first get S2 by going and substitute 2 where there is n is 2 over 2 into 5 times 2 plus 9, right? Minus S1, right? But remember, we already calculated our S1 here. We got it as what? At S7. Our S1 was 7. So we're just going to say minus 7. Don't forget to put it in brackets. So let's calculate 2 over 2 into 5 times 2 plus 9. So it's 19 minus what? Minus 7. 19 minus 7 is going to give us 12. So 19 minus 7 is going to give us 12, right? Because our S2 is 19, our S1 is 7. So let's go to S3. Term 3 is S3 minus S2, right? But we already calculated S2. We just substituted S2 here and calculated it, and it was like 19. So we're going to subtract 19 where there is S2. Then our S3, we have to calculate it where there is n. You put 3. So it's 3 over 2 into 5 times 3 plus 9 plus 9. So it's going to be 3 over 2 into 5 times 3 plus 9 plus 9. So it's giving me 36. So it's 36 minus 19. Then it will be 36 minus 19. It's going to give me 17. So my term 3 is 17. So the first 3 terms, so it's 7. Let me write it. It's 7. Oh, this pen. So my first 3 terms is 7, then 12, then what? Then 17. So those are my first 3 terms. Okay, let's now move to the second question. Determine the nth term, right? Determine the nth term. You can approach it in 2 ways. The first one can use the standard formula that I just give you. Tn is equals to Sn minus 1. Okay, how will you do this? You go and substitute your Sn, which is this one. Then you minus Sn minus 1. Where there is n, you put n minus 1. Then you simplify. It's going to be quite a long process. Then you have to simplify up until you add like terms, you group like that. Then you get your nth term, right? Or other than using this method, because you have calculated the first 3 terms, just go and get the common difference. Use the standard formula that you know and get your Tn, right? So we know Tn is A plus n minus 1 D. Our A is the first term, which is 7. Our D is the common difference, which is 12 minus 7, which is what? 12 minus 7, which is 5, right? Which is 5. 12 minus 7, which is 5. Then we can just go and substitute to get our general formula. So Tn will be 7 plus n minus 1 multiplied by 5. So our Tn will be equals to 7 plus 5n. It's going to be 5n minus 5 when we remove the brackets. So our Tn is going to be 5n. 7 minus 5 is going to give us what? 2. So this is our final answer. Tn is equals to 5n plus 2. So let me just write it there. 5n plus 2. It's our nth term. Okay, let us continue. We are going to the third question now. It's Roman figure 3. They said calculate the sum to 23 terms of the sequence, right? They need the sum of the first 23 terms. So it's going to be very simple because you already know the sum formula. So where there is n, you're just going to put 23 and divide by 2 into 5 times 23 plus 9. So this one is quite very simple. So 23 over 2 into 5 times 23 plus 9. Using my calculator, I'm getting 14 to 6. So that is the sum of 23 terms. So let's just quickly go to, so this was number 3. It's this question here. So let's quickly go also to the last one, which is Roman figure 4. It says hence calculate the 23rd term of the sequence. So they don't need S23, right? But they need the 23rd term of the sequence. So they need what? Term 23. I already taught you how you can calculate this. You say if you need term 23, you're going to say S23 minus S23 minus 1, which is S22. So you can actually memorize the sequence, how it goes if you are given some formula. S23 minus S22. So in this case, we already got S23. Hence, the question said hence, right? Okay. Just sorry for the disturbance. Let us continue. We said because we need term 23, it's S23 minus S22. But let's first calculate S22 so that we can just go and substitute and get the answer. So it will be 22 over 2 from the formula above, 5 times 22 plus 9, right? So let's get its answer very quickly. 22 over 2, 5 times 22 plus 9. Then it is 1309. So we can just come and replace there, and it will just be 1426 as our S23 that we calculate there, minus 1309. Then we can get term 2023. So 1426 minus 1309 is giving me 117. So this is our term 23. Term 23. That's the final answer. Okay. Okay, let's just do some quick recap on the topics that we covered during this revision series. We talked about arithmetic or linear sequence, where we solve different problems there. We also focused on geometric sequence, and we also focused on combination of arithmetic and geometric sequence, sometimes combination of arithmetic and constant sequence. But in this series, we focus on what? On combination of a constant and arithmetic sequence. We also focus on quadratic sequence, solving different problems on quadratic sequence, very interesting. And also lastly, we focus on sigma notation. Okay. Okay, so these are just some quick references that we used in this video. we use the basic Department of Education. You can follow their link to just get some past examination papers so that you can just treat more exam papers on number patterns so that you may be fully ready for your final examination. We also focus mainly on WTS tutoring, a document from the NCS examination past papers. So you can just download that document in the link there. Okay. Oh, this marks the end of our lesson. Thanks very much for watching us today. Mathematics has never been this easy. Don't forget to subscribe to our channel if you haven't, and hit the notification bell. Don't forget to comment and also give us some feedback so that we may improve the next upcoming videos. Watch out for the next coming mathematics revision series. That's all for me, Ndondibuo. Enjoy the rest of your day. Thank you.